afternoon. So this is going to be our presentation today. We're going to talk about pesticides and water contamination, risk assessment management for pesticides, this index that we developed in Brazil recently, the validation of the index at the field level, and once we've got high risk in this index, what we do about managing that risk, and finally the conclusions. We all know that pesticides are ubiquitous in modern agriculture. It's found everywhere where agriculture is developed, and Brazil, I think, is the second pesticide user in the world, just after the United States, so it's a huge amount. And eventually, we understand that surface and groundwater are vulnerable compartments, particularly from the leaching and runoff of those pesticides in the field. And within that, those watersheds, agricultural watersheds, we also know that man and fish particularly are threatened by those pesticide concentrations and loads. And the first question that we have is that what is the risk of water contamination by pesticides? We can more or less estimate those risks by utilizing mathematical models, which could give us, they give us the concentrations and loads of pesticides in different water compartments, surface or groundwater. But those models, they can be very complicated for the, say, extension agent and other users such as the farmer and managers in general, water managers in general. So indices could be interesting to assess that risk. And talking about models, most of the models also, they don't directly indicate a risk type result. Rather, they estimate loads and concentrations. So with that in mind, indices that could effectively measure risk could be interesting, particularly by being easier to apply and having more like a common sense type probability associated to it. And the other question would be, once the risk of water contamination by pesticides is assessed, what do we do about managing that risk to acceptable levels? So with that in mind, we developed with a PhD student at the University of Brasilia. He's part of his thesis. I have developed the model and he validated it, and we published in the Brazilian Journal of Water Resources last year what we called RAMP, Risk Assessment and Management of Pesticides. Basically, it's a very simple index. It follows the traditional risk approach used by several authors that basically it estimates the risk by the product of hazard, pesticide hazard, times site vulnerability, right there. And the thing that we did here differently, we made scorings for both indicators, namely hazard and vulnerability, going from 1 to 3, like some class variable type analysis. And of course, the product, which is risk, varies from 1 to 9. So in this lookup table here, we can see the final product of risk and the classification here, which makes the identification by the end user simpler, knowing if it's a low risk type situation or setting, medium or high. And these numbers also would give us the abatement type equation that we're going to show later. So having this in mind, we are going to present to you how we assess hazard and vulnerability. The first one being an intrinsic characteristic of the pesticide, and the second being an intrinsic characteristic of the site or the farm field, if you will. So the hazard is basically the product of the pesticide mobility given by an equation that associates KOC, which is an intrinsic property of the pesticide. The pesticide persistence, which also is a factor of the half-life of that particular pesticide. And finally, the pesticide toxicity, which is a function of the fish LD50, acute toxicity of fish, and human intake, acceptable daily intake for humans. And an average of those, because we understand that both fish and humans are as important. So once we get, for each pesticide in a given farm field setting, we calculate also the maximum product of that given pesticide, and given the precautionary principle, we assume that that pesticide with the highest hazard is the field or the site hazard, given this principle of precautionary principle. So the scoring is also similar. We have a 3-level scoring system, and these are the products of MPT for several pesticides that we analyzed for both horticulture, agriculture, and other uses in Brazil. And you can see here the type of pesticide, the type, the crop, the KOC, the mobility of that, the half-life, persistence, DL50, ADI, and toxicity, and finally the hazard and the scores. So basically we utilize here the standard deviation to more or less separate these 3 classes of hazard in this universe of pesticide that we analyze in central Brazil mostly. Of course, the ranges could be a bit higher than that, but it wouldn't be too much higher. Now, for the site vulnerability, what we used as parameters would be the product of the clay, soil clay content, the distance to the nearest water body, and the type of soil management utilized in the farm field in this particular setting. So here we have these 3 parameters, their description, and the ranges of each of those parameters, the level, and finally the scores. So basically, this would give us also a range in vulnerability, and then getting this range we multiply with hazard, and we get finally the risk. Now, why did we choose those parameters? We understand the soil clay content is strongly correlated with the adsorption coefficient. So we took basically 3 ranges in this scale, and we more or less assessed this particular vulnerability by clay content. As far as the distance from the water body from this model of freeze and cherry, we also understand that knowing this, which is much easier, say by Google, or the farmer could calculate that very easily from the centroid of his farm field to the nearest river, there's a strong correlation with the water table depth. So with that, we only knowing the X distance, we can assess also the vulnerability associated with the groundwater depth. And finally, the soil management. We also understand that in conventional tillage type conditions, the leaching and runoff of pesticides, this vulnerability is higher under this condition than, say, in no-till, because of adsorption type processes and attenuation type processes. And of course, reduced tillage would be something in between. So each of these 2 systems would get a different score based on this vulnerability. Now, for model verification or index verification and validation, what we did, we had this slope, and it's a farm field with soybeans in the summer of, I think 2 years ago, 2014. We had basically runoff and soil moisture sampling in the Vadel zone within the crop area here, and also in the river, in different 3 times during the season, just after the rainfall. So we would sample both runoff in Gerlach troughs like this, capturing runoff water, Vadel zone from soil moisture, and also river sampling. And of course, we knew the distance here, the soil clay content. We would collect samples and everything and send to the lab and analyze glyphosate concentration in this particular study. We only analyze glyphosate for this particular study. So looking at the verification of the model or index parameters, we realized in the farm field, this is basically the sampling sites within the farm field, the average of the 3 sampling dates just after rainfall. We verified that the glyphosate concentration is pretty much associated with the clay content of the site, right? And also the distance from the river to the river is also strongly correlated with the glyphosate concentrations given by these 2 graphs. Now, after estimating basically all the parameters of the index, MPT for glyphosate, we got 0.37, and according to that table I showed you before, the score would be 1. And also the vulnerability parameters, clay content, the average distance of the centroid of the area of the farm field, and it was a no-till soybean field. We get a vulnerability of 2, and 2 times 1 gives 2, which would be associated with a low score or a low level of risk. Now, what we did to validate the model, we compared the mean concentration of the glyphosate in the river, and this river was only inside this farm. It's like a small stream that has its source within the farm, so we knew that the only source of glyphosate would be that particular farm field. So the average of the concentration measured in these 3 sampling dates was 4.7, I think. And this is not TDML, it's MCL. That's the MCL for Brazilian surface water and groundwater, which was well above the sampling concentration of the river. So this would give us that this particular concentration would be below the MCL for good quality water. So that more or less validate this low risk of contamination after rainfall and runoff and base flow and so on. So with that, we understand that the index more or less correlates correctly with the final concentrations downstream for both surface and base flow. Now, if we have other pesticides and other risks or in other farm settings, and we get, say, a high risk of water contamination by pesticide, what we do about that? So the idea would be to replace pesticides with high hazard with ones that have low hazards. Change, say, soil management from conventional tillage, say, to no-till. That would reduce this vulnerability. And try to move this farm field or crop area upstream, so we reduce also the vulnerability to be close to the water sources. And we could utilize, say, this equation, very simple equation that the farmer could use once he knows the risk before and after the adoption of the best management practice or practices, and calculate, say, the risk before, R0, and risk after, and then, say, estimate the risk abatement here, these three classes. And what we're trying to do in Brazil with sediment abatement and paying for ecosystem services, particularly in watersheds that are supply sources, we could do the same for paying for hydrologic services of reduction of risk by pesticide contamination. So the farmer that would adopt this best management practices and effectively reduce his risk, he would be compensated financially by, say, downstream water users. So that's what we're using already with sedimentation. We could easily move toward pesticide contamination in water. So these are the final conclusions. Risk of water contamination by pesticides can be assessed by indices. And this index called RAMP is a simple and promising tool. It allows for practical water contamination risk management, but we still need to validate it in other farm settings with different pesticides and eventually in other countries. And we will be very welcome to share with you this technology and try to validate it in your country or your farm setting. Thank you very much. Just finally to say this, we try to emphasize this pesticide type contamination issue within the UNESCO graphic program. We have some American colleagues already that participate in that. So here's our contact, and we're welcome to answer any questions. Thank you.
Questions?
Thank you for the presentation. I guess I have a few questions. So this risk assessment is mainly for pesticides movement to surface water or also groundwater? I'm asking because you're also measuring the vadose zone, so I wasn't sure. That's the first. And the second is, who is measuring the parameters of each pesticides, mainly the persistence and mobility? Is that the government of Brazil measuring that, or who ranks those pesticides?
The first question is, okay, both surface and groundwater, it could be assessed, and there's the risk for both of them. Groundwater by leaching, and surface water mostly by runoff. So both, as I showed you the model of freeze and cherry, but we only measure, say, because it's much simpler to measure the distance of the farm field centroid to the river. But associated or correlated with that, we have groundwater depth in that model of freeze and cherry. So I would say both, particularly in the river. When we sample, we were eventually collecting those concentrations that would come, say, from surface water and also from base flow. We didn't know exactly the source, but I would say that this index could be used for both, assessing both risks of both compartments, groundwater and surface water. And secondly, the three parameters for pesticide hazard, toxicity, mobility, and the last one was toxicity. They can be found in UPAC sites. You know, it's in chemical type sites, UPAC. You can find all of those over the internet for all pesticides that exist in the world. So they're there, you know, just look it up, and they're in tabled, you know. Thank you.